So this is chapter 23 homework. We went through a lot of these in class. I won't go over most of them again. With this one, again, you can see the answer. R3 is greater than R1 is greater than R2. Let's do the steepness of this graph. Pardon me. Question 9 is here. All the voltage provided by the identical batteries must be dissipated across the resistors. So therefore, the voltage of A to B is equal to the voltage of C to D. I think I'll explain this in class. I kind of pushed him a little bit on it, but that also implies that while the current is less here, the resistance is greater. Same voltage dissipated here as here. In terms of the currents, current through circuit, the left circuit is greater than the current through the right circuits. This one would be a 6-volt power source, 2 ohm and 1 ohm resistors. So I need 3 ohms total resistance if the current is 2 amps. And the maximum potential is 6 volts. So my position of resistors doesn't match very well. So for example, if you look this, the distance between the last resistor, which is where you have a negative slope here, and the battery, which is where you have a positive slope, is very small. So that means that this 1 ohm resistor to the battery should be a short distance. It's not bad, not great. So I think it's the 6 volts, and away from the positive side would be a 2 ohm resistor, and then after that a 1 ohm resistor. Number 22, the batteries provide a total of 7.5 volts of potential. 5.5 volts are used across these 2 resistors. That leaves 2 volts across this resistor. If it's 150 ohms and uses 2 volts, it gives me a current of 0.013 amps or 13 milliamps. Excuse me. 30 we went over in class a lot, and you can see I screwed up when I initially did this because I was taking too many steps at a time. Start with the outer part and work my way in. That's a 12 ohm resistor. All of this is a 4 ohm resistor. Well, I wasn't thinking well about that here. So this equivalent became a 4. So then the 4 and the 8 are in series. That makes it 12. And now this 6 and this 12 in parallel give me a 4. Again, I screwed that up initially. That's a 4. This 4 and then this 4, which is really this 4, are in series. That makes an 8. 8 ohm resistor here. Now I've got an 8 ohm and an 8 ohm in parallel. That makes a 4. Now I've got the 4 and the 6 up top are in series. That gives me a 10. And finally, we've got a 10 in parallel with an 8, and that gives me 4.44 ohms. And that will give me a current of 1.35 amps through the battery. 33, a little bit easier one. Find the current and potential difference across each resistor. Here's my simplified diagram. Because all 3 of these are in parallel, they are equivalent to 3 ohms. So I've got total resistance of 6 ohms, total voltage of 12, total current will be 2 amps. 2 amps times 3 ohms gives me 6 volts across this first resistor. Therefore, in any of these 3 paths, which the current goes, I have 12 minus 6 volts, or 6 volts left. That's why all these happen to be 6 volts. 2 amps times the equivalent resistance of that part of the circuit. To find the current in each individual branch, now I'm going to zoom in on that branch and take 3 volts divided by 4 ohms, 3 volts divided by 48 ohms, 3 volts divided by 16 ohms. (62) we talked about a lot in class. It was very sneaky. This point is at 10 volts, this point is at 0 volts, and this point is at 10 volts, and that point is at 0 volts. And we drew on the board the 3 paths the electricity could flow. Each of those paths, you would go through a 10 ohm resistor, and therefore the total current Be 1 amp through each of those resistors, 3 amps total. We can work our way back from that and get the fact that essentially we've got a 3.3 ohm circuit. 2 amps is going through this top branch, and 2 amps will be going through this bottom branch down here. Much tougher problem than it initially looked. Finally, with P72, find V and I for each resistor. I put an asterisk next to this 24 ohm resistor so we could tell it apart from this one. First thing, get total resistance and total current. You can see my arrows leading me down here. I'm going to get a total resistance of 12 ohms, total current of 2 amps. That happens to be what's going through the 4 ohm resistor. The 6 ohm resistor is here. So essentially what I can do is I can say that across this branch and across this branch, I can figure out the voltage across that, and then I divide by the resistance of that branch to figure things out for the 6 ohm resistor. I actually ended up doing this 24 ohm on the outside first because it's all by itself. So essentially if I use 24 volts in the circuit and I've used 8 volts across this, I have 16 volts left across this outer branch. 16 volts divided by 24 ohms, 0.67 amps. Then I'm going to go back and attack the 6 ohm resistor. Well, I already figured out I have 16 volts across this part of the circuit. That means it's 16 volts across that part of the circuit. 16 volts divided by 12 ohms is going to be 1.33 amps. The other way you could say that is if I start with 2 amps and then I use 0.67 amps through this outer branch, then whatever is left is 1.33 amps is going through here. And then I could do 1.33 times 8, or 6 ohms is equal to 8 volts. There are other ways to get this, but that's probably the most straightforward. Then I look down here and I say this equivalent resistance is 6 ohms. 6 ohms times 1.33 amps is going to be 8 volts. Or you could remember that this whole part here is 16 volts minus the 8 volts that was used up here. You've got 8 volts left across both these resistors. So that's across the 8 and the other 24. For getting the current through those resistors, we're going to super zoom in on them. Only look at the voltage across each individual resistor, the resistance of each individual resistor. And that's how I get my current here of 1 amp and 1.33 amps. So it's really a methodical process. These were all few type problems because they were pretty challenging. Phew, tough problem. This one took a whole page and I had like 4 scribble outs. Geez. So you get the fact that this was challenging, and it was. So hopefully this makes sense. These are definitely complicated circuits.